This is a continuation from the P3 notes that we took yesterday. So all we're going to do here is, these are not all square roots. So just take a look at 20, 21, 22. Look at these examples. 20 is a cube root. If it were a square root, there would be no number in the place of the little 3. So 20 is a cube root, 21 is a fourth root, 22 is a fifth root. So 20 is asking you, what number cubed is 64? What number cubed is 64? So you could use your chart. You could go down to x cubed until you find a 64, and then go over to the left. What number cubed is 64? 4. Example 21 says the fourth root of 16. That means what number raised to the fourth power is 16? 2. Example 22 says what is the fifth root of negative 243? Now in the past, when we saw a negative underneath our square roots, what 3 words did we write? No real number. Okay? Now turn your brain completely on. You cannot take an even root. That means your index, your little number, cannot be even if the number underneath is negative. Because nothing times itself an even amount of times ever produces a negative. Okay? Anytime your little number is even and you have a negative number underneath, the answer is no real number, because you can't multiply a negative times itself an even amount of time and get a negative, because a negative times itself an even amount of time is always a positive. So is the index in number 22 even, or is the index, or the little number, that's what the index is it odd? It's odd. So I can get an answer here, and if there's a negative underneath my odd index, then the answer is going to be negative. Okay? The only time you're going to write no real number is when there's a negative under the radical and the index is an even number. So use your chart. What times itself 5 times is 243? 3. Okay? So let me make sure you understand your answer. You're telling me that negative 3 times negative 3 times negative 3 times negative 3 times negative 3, 5 times is negative 243. That makes sense. A negative times itself 5 times is a negative because 5 is odd. Alright, now let's go to example 23. What is the fourth root of 81? No. Can't do that. Why can I not take the fourth root of negative 81? The index is even. You can't multiply anything times itself an even amount of times and get a negative number. So example 23 is no real number. All right, if you need to write this down, a note to yourself, and 22 and 23 should show you when you write no real number and when you bring down the negative. So in 22, if you want to draw a little arrow to the 5 and say the 5 is what? Odd. Okay? If you want to draw a little arrow on example 23 on the 4 and write even. You can't take an even root of a negative number. But you can take the odd root of a negative number. Alright, example 24. What is the cube root of 54? Use your chart. What is the cube root of 54? Perfect cubes are 1, 8. What's the next number after 8? 27 and 64. They must have left 54 out. Or is 54 not a perfect cube? 54 is not a perfect cube. Well, we dealt with numbers that weren't perfect squares. What number will go into 54 that's a perfect cube? 27. So we're going to have to break down 54 into 27 times 2. Okay? Keep telling your brain, this is not a square root. This is a cube root. If you're not careful, your brain is just going to fall back to square root because that's what you've done for 16, 17 years, 15 years, however how old you are. So now we got to take the cube root of 27 and we're going to mark it out. What's the cube root of 27? 3. 3 comes out, and then you're left with the cube root of 2. You do have to put your little 3 back on the radical. If you don't put your little 3 back on the radical, it turns into a square root. It's not a square root, it is a cube root. Example 25, the cube root of 24. Look at your chart. Is 24 a perfect cube? No, but what number will go into 24 that is a perfect cube? 8. So we're going to break this down into the cube root of 8 times what? 3. 8 times 3 is 24. The cube root of 8 is 2. 2 comes out, and then you're left with the cube root of 3 on the inside. So that simplifies to be 2 cube root of 3. Any questions before we move on? Example 26. What's underneath, guys, is not simplified. So I want you to simplify what's underneath and get one number. So what's a negative 2 in parentheses raised to the 4th power? 16? Positive? Positive. Okay? So we don't want to take the radical of more than one number. If we can simplify what's under that radical, let's simplify it. So negative 2 in parentheses raised to the 4th power is positive 16. Is 16 something I can take the 4th root of? Is it underneath x to the 4th on your chart? Yes, it is. What times itself 4 times is 16? 2. So the answer is just 2. No radical, because 16 was a perfect 4th. It was something you could say. What times itself 4 times is 16? It's just 2. There's nothing left over like in example 24 and 25. All right, y'all ready to add variables? All right, we're going to do it whether you're ready or not. Example 27. We're under a cube root. Is 16 a perfect cube? It is? No. 16 is not a perfect cube. It's a perfect 4th. But what will divide into 16 that is a perfect cube? 8. Okay, so we're going to break 8 down into, so we're going to break 16 down into 8 times 2, and we're just going to bring the variables down. Okay? We're going to take the cube root of the variables just like you took the square root. I don't have to teach you anything new about the variables, but let's start with the first number under your radical. What is the cube root of 8? 2. So you're going to mark out the 8, and you're going to bring out a 2. Mark out the 8, bring out a 2. The next 2 just has to stay under the radical. Then go to the next variable. It's an x. You always take your index and divide it into your exponent. So 3 goes into 3 how many times? Once. So x to the 1 comes out. Anything left over after 3 goes into 3? No. So you cross the x completely out. There will be no x under your radical. Go to the next variable. Does 3 go into 5? How many times? Once. So y to the 1 comes out. Anything left over after 3 goes into 5? Yes. What? 2. So y to the 2 has to stay under the radical. All right, so 2x is outside, and then you're left with the cube root of what? What have I not marked out? 2y to the 2. 2xy is on the outside, and then I have the cube root of 2y squared underneath. Example 28, we're under the 5th root. We're under the 5th root. Tell your brain, 5th root, 5th root. Is 32 something I can take the 5th root of? Yes, it is. So I'll mark out the 32. What times itself 5 times is 32? 2. So I bring out a 2. I go to my variable. My variable's exponent. The x's exponent is a 1. Can you divide a 5 into a little bitty 1? No, so you have to leave that x under the radical. If the index won't divide into it because it's smaller exponent, you just leave it there. Go to the next variable. Will 5 go into 5? Yes. How many times? 1. So you bring out a 1. Y to the 1 out. Anything left over after 5 goes into 5? Nope. So you cross out the y. And the only thing I have left under my 5th root is x. So my answer is 2y 5th root of x. 2y 5th root of x. Questions about 28. Again, if you see some absolute values in your answers, just ignore those. We're not going to go there. All right, example 29. You can multiply a fourth root times another fourth root, but you just can't multiply a fourth root times a cube root or a fourth root times a square root. So I can multiply these two fourth roots together and put the answer back underneath the fourth root. So that's going to give me the fourth root of 32. Then you're going to take a look at your purple sheet, and you're going to ask yourself, anything times itself 4 times is 32? Anything times itself 4 times is 32? No, but what will go into 32 that I can take the fourth root of? 16. So I'm going to break that down into the fourth root of 16 times 2. This is where you got to slap yourself sometimes. You're not taking the square root of 16. You're taking the fourth root of 16. What's the fourth root of 16? 2. So 2 comes out, and then you're left with the fourth root of 2. 2 fourth root of 2. The concept is exactly the same as the square roots. We're just changing the index. We're just changing the index. Okay, and this is new, all right? Algebra 2, I think 99%, you're just dealing with square roots. All right, example 30. Y'all should tell me how to do 30. Just remember it's the fourth root. The answer is, say it louder, 3 over 2. Anytime you have a fraction underneath your radical, you probably can just take the radical of the top and then the radical of the bottom. So the fourth root of 81 is 3. 3 times itself 4 times is 81. And the fourth root of 16 is 2. If you're not careful, what index will your brain default to? Square root. So you got to tell yourself, what index am I using? Because I'm not in square roots anymore. I've graduated to Algebra 2. I'm not doing square roots all the time. I'm getting to do other indexes. All right, any questions through number 30? All right, flip over on the back. Apparently now in the middle school they are teaching rational exponents. I don't know if you were in the middle school when they started teaching them, so I'm going to teach this like you've never seen it before. A rational exponent. Rational means anything that can be written as a fraction. So we're talking about an exponent that is a fraction. Okay, not only is it an exponent, but it's a fraction. The top of that exponent is the power. The top of the exponent is the power, and the bottom of the exponent is the index. So let's look at example 31 together. We're going to do the index first, okay? In most situations, we do the index first. So in example 31, 3 is the index. So in your mind or on your paper, you're going to rewrite this in a radical form until you catch on to what you're doing, and then some of y'all are going to be so smart, you're going to be able to do these on your own. So that 3 on the bottom of your exponent that is a fraction really says the cube root of 27. Later on, you're just going to visually see this. It's the cube root of 27 raised to the power of 2. The top of the fraction is the power, the bottom is the index. You're going to do what's in parentheses first. The cube root of 27 is 3, and 3 squared is 9. Believe me, you'll start to do these totally in your head. You won't have any work. When you start to see that exponent that's a fraction, you're going to know that the bottom represents the index and the top represents the power. Just do the index first because it makes your index makes the number smaller right off the bat. So let's see if we can do 32 in our head. We're going to do the index first. What number represents the index? The 2. So that means the square root of 9. Can you do that in your head? What's the square root of 9? 3. And then you're going to raise 3 to what power? The third power. And what's 3 to the third? 27. Okay? If you can't do that in your head, then you'll write it out like we did in example 31. But those two are meant to kind of do in your head. The bottom is the index. The top is the power. All right? 33. Not only do I have an exponent, it's a fraction, now it's a negative. But we know negative means take the reciprocal or the I word. inverse. So that really just means 1 over 81 to the positive 3/4. So 81 to the negative 3/4, all that negative means is just take the inverse. Now what's the index, the 3 or the 4? 4 is the index. So see if we can do this in our head. The 4th root of 81, use your chart. The 4th root of 81 is 3, and 3 raised to the 3rd power is 27. So the answer to this one is 1 over 27. The bottom number of the fraction is the index. The top number is the power. Example 34. We need to multiply these two terms together. All right? 34 is not simplified because we've got to do 5 times 7. What is 5 times 7? 35. We've got to multiply our x's together. How do we multiply like bases together? Say it louder. You add their exponents. So I've got to add 1/2 with 3/4. In the 4th grade, I learned that I can't add or subtract fractions unless I have a common denominator. So what's the common denominator here? 4. So I want to think of that 1/2 as 2/4. So what's 2/4 plus 3/4? 5/4. So my answer is 35 x to the 5/4. All right, you can't go any further there because x is not a number. It's a variable. So you can't take the 4th root of x because you don't even know what x is. That's just your answer there. All right, how did I get the 5/4? And why did I add the exponents? Because I'm multiplying. All right, example 35. Example 35, we have a quotient. We have a division problem. So let's start with 32 divided by 16. What's 32 divided by 16? 2. 2 in the top or 2 in the bottom? 2 in the top. All right, now we have to divide our x's. How do we divide like bases? We subtract. We can't subtract or add fractions unless we have a common denominator. What's that going to be? What's that going to be? 12. So let's change both denominators to a 12. What is 5/3 as a 12th? 20/12. What's 3/4 as a 12th? 9/12. Which fraction is smaller, 20/12 or 9/12? 9/12. So you're going to bring the 9/12 up and you're going to subtract it from the larger exponent, 12/12. So 20/12 minus 9/12 is 11/12. That's going to be the exponent on your x. Everything moved up to the top, so I'm left with an understood 1 on the bottom, and you won't write that understood 1. You'll just kind of erase this little fraction bar. There's a 1 right there. My eraser's too big. Let's try to make it smaller. You can just erase that little fraction bar right there. If everything moves up to the top, you can just write the answer as 2x to 11/12.
Thank you.
You're welcome.
Been in hospital till bedtime every night and something. Thank you.
Glad to help you.
Thank you.
All right, questions about 35? Almost finished. All right, last 2 examples. Reducing the index is a way to simplify a radical. Reducing an index is a way to simplify a radical. All right, so in 36, after everything that I've showed you, 9 is not going to divide into what? 3. 9 is too big. If the index is too big to divide into the power that's under your radical, ask yourself, can you reduce the 9 and the 3? Is there anything that will go into 9 that will also go into 3? 3, okay? So it is legal to reduce your index as long as you reduce all of your exponents under your radical by the same number. So we're reducing by 3, and you can show that on your notes by we're dividing everything by 3. So the index is no longer a 9, it is a 3. The exponent on the x is no longer a 3, it is an understood 1. Okay? So can you in your mind understand why the cube root of x would be a more simple way to write the 9th root of x cubed? It's just considered simplified. Okay, we're going to do the same thing with 37. 12 will not go into 4 because 4 is too small. 12 will not go into 8. So if they're asking me to simplify this, the only way to simplify it is to find a number that will go into 12, 4, and 8. And what's the biggest number that will go into all those? 4. So we're going to reduce everything by 4. So what's the index going to become? A 3. So we're going to have the cube root of x, y to the second. The cube root of x, y to the second.